So when we try to divide two complex numbers, so you have a complex number in the numerator and a complex number in the denominator, what you need to do is somehow convert this denominator into a real number. So we need to get rid of the imaginary component. We do that by multiplying by something called the complex conjugate. So we multiply by the complex conjugate. And it's only the denominator we're interested in. So we look at this, and then we multiply by the complex conjugate, which is the same real component, but then we reverse the sign of the imaginary component. Okay, so it's only the denominator that we use. But then we write that twice. We write it both in numerator and the denominator. So as if you're multiplying by 1, because this is just 1. So it's as if we're not making any change. But what we're actually multiplying by is the complex conjugate in the numerator and the denominator. But it's the complex conjugate of the denominator. Okay, so that's the first thing we need to do. We need to multiply by a version of the denominator with a reversed sign. The sign for the imaginary bit needs to be changed. Okay, so that's step number 1. Now, what we actually have is multiplication. So, in order to multiply complex numbers, you need to multiply term by term, and you need to do the numerator and the denominator. So we're going to do it term by term, numerator first, denominator next. So if we look at the numerator, you're going to multiply 2 by 4, and that will give you 8. Then you multiply 2 by negative j2, that'll give you negative j4. Then you repeat that process, but you do it for the second term. So the j3 times 4 and the j3 times negative j2. So j3 multiplied by 4 is simply j12, and then j3 times negative j2 gives you negative j squared 6. Why j squared? Because we're multiplying j by j. Now, that's the numerator. We do the same for the denominator. So let's make some space. So we multiply the 4 by the 4, and then the 4 by negative j2. So 4 times 4 is 16. 4 times negative j2 is negative j8. Then we do the same for the j2. So we multiply it by both terms. So you get plus j8. That's j2 multiplied by 4. And then the j2 multiplied by negative j2 will give you negative j squared times 4. Now, again, we've got this j squared term. Now remember, definition of j is the square root of negative 1. So by definition, j squared is negative 1. So whenever we see j squared, you can replace that with negative 1. So replacing j squared with negative 1 will simply change this negative sign to a positive sign. And this negative will change to a positive, because it's as if we're saying negative times negative 1 times 6. So negative 1 times negative 1 is positive. We can also combine these like terms. These add together, and these add together. But the special thing to note about the denominator is that these cancel out to 0. And that's exactly what we wanted. We wanted the denominator to be real. So when these cancel out, as you'll see, we'll end up with a real denominator. So 8, we'll write that the way it is. And then you've got negative J4 plus J12. That gives you plus J8. And then the negative times negative gives you plus. So that's plus 6. And again, these like terms, they add up. So let's just finish the numerator. You've got 14 plus J8. And for the denominator, negative J8 and positive J8, that gives you 0. This negative and negative becomes positive, so you have 16 plus 4. So that gives you 20. So this could be your final answer, except we'd rather not have a fraction bar. We'd rather have a real component plus j and an imaginary component. So what you can do is separate this into 2 fractions. So we can write it as 14 over 20 plus j 8 over 20. Again, 14 over 20 and 8 over 20, both of these can be simplified. So 14 over 20 is 7 over 10, which is just 0.7. And 8 over 20 is 4 over 10, which is just 0.4. So j 0.4. So that is your final answer. So that's how you would divide complex numbers. What you need to do is multiply by the complex conjugate of the denominator. And you do that twice, in the numerator and denominator. So effectively, you're simply multiplying by 1. But the result is the denominator changes from something that's complex to something that's real. So 20, that's real, and now you end up with a complex number. I hope you found that helpful.